Assalamualaikum and a very greetings to everyone. Today, me and my group members are going to present about our PBL assignment and the subject Beke 2333 Analog Electronics. Before that, let me introduce myself. My name is NAYLI binti RAHZANI and this is my group members Iryani, NURUL NADIAH and AFIQAH MUNIRAH. Our task is to design a Class AB amplifier for a CD player system with a 6 ohm speaker. The system is required to have approximately 4 watt, and from the design circuit, we need to determine the advantages, the power dissipated, the useful power being delivered to the load, and their efficiency. So basically the assignments are given so that students are exposed with the application regarding the power amplifier and demonstrate the design circuit by relating to its theoretical concepts. Actually, power amplifier is widely used in application like audio and radio equipment as part of the system before further processing into other significant parameters. Okay. Right now, the slide is presenting the circuit and DC load line of Class AB amplifier. As we can see, the circuit consists of two diodes which are placed between the transistor's bases. This circuit configuration can be called as Class AB amplifier diode biasing. Okay, the application of diode biasing can be easily accomplished in modern day integrated circuit amplifiers such as LM3X6 audio power amplifier. Okay, the advantages of Class AB amplifier is because of the circuit consists of two diodes. These diodes will eliminate crossover distortion and thermal runaway that occur in voltage divider bias. So basically, these problems happen in voltage divider bias circuit in order to develop Class B amplifier. So next, the description of Class AB amplifier. Okay, firstly, Class AB amplifier output stage combines the advantages of Class A and Class B amplifier in order to produce a better power amplifier design. Secondly, the Q point of Class AB amplifier is above Class B but below Class A amplifier. Beside that, in Class AB operation, the transistors conduct for the portion of the input cycle that are greater than 180 degree and less than 360 degree. Okay, in addition, the power efficiency of Class AB amplifier is between 25%, 50% and 78.5%. Okay, the objectives of our task, first, to design a Class AB amplifier circuit in producing desired output at load. Second, to perform simulation analysis using simulation software such as PSpice, Multisim and Proteus. And lastly, to apply the theoretical learning and concept in class through practical circuit simulation.
Assalamualaikum. So my name is Iryani. I would present about PHILAS table. PHILAS table consists of facts, ideas, learning issues, actions and solution. So here is the PHILAS table. So for the questions number 3, we need to design a Class AB power amplifier that produce a 4 watt output. So this 4 watt output will go through to our load, which is 6 ohm speaker. So we need to know what the load voltage for the power output 4 watt. So by using the formula VL peak equal to P naught AC times 2RL, square root all of them, we will get 6.93 volt for voltage load peak. So the second problem is we need to form a class AB power amplifier. As we know, class AB power amplifier is actually came from the addition of class A principal to class B power amplifier. So from that, we know that we will add the voltage divider at the BJT transistor base. So from the formations of the class AB power amplifier, we need to determine the value of R1 and R2. So by that, we assume R1A equal to R1B equal to R1AB equal to 100 ohm, R2A equal to R2B equal to R2AB equal to 100 ohm. So the second problem is a thermal instability problem at VBE junction due to the voltage divider from the second problem. So we know that Q point is not maintained due to the changes of value of VBE that affect the heat. So what is the substitutions of VBE that will not damage the transistor NPN and PNP? So we're using a 0.7 volt diode that have a same principle as a junction VBE. As we know, V diode equal to VBE equal to 0.7 volt. So here is a figure for the circuit. Before we got the class AB power amplifier circuit. After this, my friend will continue about that. So this is a class A power amplifier that being added to the class B power amplifier. Then it will came out like a figure 3, but at the voltage divider at here at the transistor base will be replaced with a diode D1 and D2 that have same principles as VBE to avoid overheat. That's all from me. Thank you.
Hi, my name is NADIAH binti MOHAMMED. I will explain the result of the simulation. So first of all, this is our circuit design of class AB for this assignment. The devices state with the two commonly used small signal fast switching diodes. These diodes are connected in series along with the two biasing resistors, which is R2 and R3. The output stage is fitted with the load resistor, which is RL of 6 ohm, represent as speaker, and AC signal with 120 Hz with 7 volt SCD drive. To obtain output for the full cycle of signal, it is necessary to use two transistors, and have each conduct on opposite half cycle. This circuit also called as push-pull circuit. So let's proceed to the next slide. Here we have the waveform of V in, V out, and I load. For the circuit, its VCC is 20 volt and it will conduct current only for transistor Q1. Due to that, it will produce 1/2 positive cycle for output voltage. The signal waveform for current load also 1/2 positive cycle. So the value peak of input voltage is 6.9333 volt, and for the output voltage is 6.7810 volt, and lastly for the current load is 1.1351 ampere. So for the next circuit, its VCC is negative 20 volts. It will conduct current only for transistor Q1. Same goes as before, it will produce 1/2 negative cycle for output voltage and load current. So for its input voltage, it will be negative 6.9333 volt, and output voltage is negative 6.7810 volt, and also for the current load is negative 1.1351 ampere. So this is DC load line for simulation and manual calculation. For the Q point in simulation, it is a bit far from the Q point in manual calculation, but based on what we have learned in the class, both Q point on DC load line from simulation and calculation got same as a theoretical, which is above class B and below class A.
Assalamualaikum and salam sejahtera. I will present about analysis and discussion. For analysis, we can see we have two tables, which is table AC analysis and also DC analysis. For DC analysis, we have get the for DC analysis, we have get the value of ICQ and also VECQ to get the load line. For the calculation, for ICQ, we get a value of ICQ is 0.193 ampere, while for our simulation, we get a value of ICQ is 1.33 ampere. For VCEQ, we find the value is the same for simulation and calculation, which is 10 ampere. For this result, we find the point Q is the same point at the same point. For AC analysis, we have find the value of voltage load, current load, power input, power output, and power dissipate. For simulation, we have two value, which is for positive cycle and also negative cycle. For negative cycle, the value will be negative and vice versa for positive cycle. For the value of voltage load, we find that the value of simulation and calculation is the same, which is 6.93 volt. Next, for I load, we get the simulation value, and simulation value is 1.13 ampere, while calculation we get 1.16 ampere. These two value approaching to each other. Next, the value of power input, which is 14.4 watt for simulation, while the value of calculation we get 40.8 watt. For the answer approaching each other. Next, for power output, the simulation we find a value of 3.8 watt, while for calculation based on the question, which is 4 watt. Lastly, for power dissipate, we get at the simulation we get 5.28 watt, while calculation we get 5.4 watt. This answer also approaching to each other. Next, I will present about discussion. In this question, we construct class AB amplifier in the Proto simulation software. We have seen here that a class AB amplifier is biasing so that output current flow for less than the full cycle of the input waveform, but more than a half cycle. This used for complementary output stage, which is transistor conducting opposite half cycle of the input waveform before combined at the load. The effectiveness of amplifier is measured from the efficiency. Efficiency defined as ratio of power output to power input. For the class AB efficiency, for this case, between 25% to 78.5%. When we make the calculation, we find that the efficiency for this question is 27.03%, and from the simulation we get 26.63%. This answer is approaching each other. When the efficiency we get below 15% because they happen because the input current is lower. When we make a comparison, we find the simulation and calculation are similar in the theory.
So, for the conclusion of this assignment, we were able to perform simulation analysis by using computer software, which is multi-sim. Class AB power amplifier helps significantly to reduce crossover distortion and terminal instability problem. Class AB, widely considered as a good compromise for audio amplifiers, Result based on simulation approximate the same with the calculations. Thank you, that's all from us. Hoping that you have a good day ahead. Stay at home, stay safe, and take care.